Hello everyone, I'm Muhammad Akif Hussain and I am more than excited to share with you another project I have been working on. And it's called the multi-parameter device. That's because it can measure the height of an object. In case of liquids, it will be the depth of a liquid, the temperature of an object or liquid, and the voltage passing through a conductor, all contactlessly. So first we shall look into the device itself, its views, and then we shall look to the features of the device, and finally we will come to the application of it at my home, using it at my home, and when it is used in the industry. So of course it's fine-tuned to the industry standards and requirements. However, it's a proof of concept of what can be possible for similar devices. So without wasting any time, let's dive in. So this is a showcase of the device itself. The leftmost is the front view of the device, the middle one is the side view, and the rightmost is the rear view of the device. A point to note that it's so lightweight and small that can easily be held and carried. And also notice that the hook attached to the device will help it to be attached to any support. So this is a comprehensive analysis of all the features the device has to offer. It has two modes, online and offline mode where internet is not available. The online mode, as you may already know, will have all the values, the data stored onto a database, which can be viewed by verified users. However, non-verified users can live view the data remotely using a web application, EGA innovate.web.app. So it's a web application and it can be used on a mobile phone, on a laptop, personal computer, etc. So coming back, both the online and offline modes will have three features, parameters, which the device is offering as I talked about earlier. So the first one was height of the object or depth of a liquid. The second one was the voltage passing through a metal conductor. And the third one was temperature of an object or liquid. So all three of these will have the replacement values stored. So what this means is the device has an internal storage as well as an external storage, which is the database. So in its internal storage, it will have all the placement values stored, which means you can find out what's the first value you saved, the fifth value, the hundredth value you saved. So specific placement values you can check using this device. The second feature is it can tell you the average of all the values stored or recorded. The third one is the smallest amongst all the values, and the fourth it can calculate is the largest value amongst all the values you stored. And of course, all four of these can be live viewed remotely from a mobile phone or laptop, etc., using a web application by verified users or non-verified users.
So this is the object height, any object height measuring mode. I turn it on in internet mode by pressing the right button and then turning it on. Yeah, it flashes a purple light showing it is turned on in internet mode. I press 0 and then enter it, which is the mode for measuring any object's height. Hovering it simply over an object shows 6 centimeters, then 7, and then 7. It updates all of this in real time automatically by flashing the white light in the real-time database. So now we need to check some specific features. I press the left button and see the first value, which was 6, which was saved. The second value which was saved was 7, and so on. The third was also 7. Now I need to see some more specific features like the average, smallest and largest. So the average was 6 and the smallest was 6.6667 was the average, the smallest was 6, and the largest was 7. Okay, and we are done with all the features of this mode. Now let's turn it off. Yeah, so I couldn't show the websites real time in the previous frame because it was just so compacted. So initially the value was 1, then changed to 6, and then 7. The average was 6.6667, the smallest was 6, and the largest was 7, as it was shown previously. This device can also measure the depth of liquids like water in a container. So it shows a varying height of around 6, 7. And this is a quick flame test as it's covered with fireproof cloth. The device in the industry measures ACRM height of 8 centimeters, which is verified by the scale markings on the left. The device can also measure and store the temperature of objects. However, there is a little bit of error compared to the industrial grade temperature measurement device on the right, which is one of the reasons for a little bit of error in the voltage calculation later on.
Earlier, there was a little error in the temperature measurement using my device. Analyzing the video, I saw that the industrial temperature gun had an emissivity calibrated by a company for them was set to 0.99. However, the emissivity of my measurement system was set to 0.95. So, correcting it should yield the correct temperature. A brief intro about what is CD. CD is essentially voltage which is passing through the anode bar and is measured from the front of the anode bar. And clamp drops, on the other hand, are measured from the side of the anode bar, and that's because clamp drops are the voltage drops due to the connection between the bus bar and the anode rod. Both the labelings you can see, and the devices you can see are probe rod. So probe rod is the current technique used to measure voltages with contact in millivolts in the industry. One thing you will note later on is the voltage values on the probe rod will be very variating quickly. So there will be no one single value which you can record and store for later on. That's not because of some error of this device, but possibly the voltage causing through the node bar are variating. So I wanted to solve this issue. However, the temperature measurement system I used, it is one of the ways, one of the variables to calculate the voltage. It was also variating. That's because even if you move your temperature gun or temperature measurement system by 1 degree when you're pointing to an object, if you move by 1 degree 4 meters away from the initial point, that point may have deviated by 4 centimeters. So there's a different temperature value. So that's why it's constantly changing. However, once a user is viewing it, it can extract out the most stable value from all of the temperature values that the temperature measurement system shows, and then enter it manually, of course, and then obtain one single millivolt value, as you will notice later on.
Now here we have a CD demonstration which, using my device entering 81 degrees Celsius, measures 0.50 millivolts, and using the probe rod measures 0.5 millivolts. And moving on to the next anode bar, coincidentally it had the same millivolt value, which was 0.5. Using my device measuring 82 degrees Celsius, entering it shows 0.52 millivolts, about same. Now here is a demonstration of the voltage calculation in millivolts in the operational area. The probe rod measures about 5.5, 5.6 millivolts, and using my device, checking first the temperature, entering 77 degrees Celsius, measures 5.48 millivolts, about similar. Now here we have another voltage demonstration where the probe rod shows around 7.7, 7.8 millivolts, and using my device, first checking the temperature and entering 84 degrees Celsius measures 7.58 millivolts, around near to each other. One last voltage demonstration where the probe rod shows about 8.2, 8.3 millivolts, and using my device checking the temperature, entering the value 88 because for some reason the 9 button failed to work at the moment to enter 90 degrees. However, entering a closer value which was 88 measures 8.24 millivolts, a much more similar value to the true millivolts using the probe rod.
Okay, so now let's talk about some of my future aims with this project. The first one is solar charging. So, as you can imagine, if an area has molten aluminium nearby, so that area will, of course, be very, very hot. So, we can utilize that heat energy to produce electrical energy using a solar panel, and that can charge our batteries and that can charge the device as it's being used simultaneously. So it never runs out of battery. And that's what I will be doing very soon. Secondly, I will be adding volume calculation method or mode into this device. So as I have proven already that the sensor can measure the depth of a liquid in a container. So let's suppose if the container is an anode cell as illustrated on your left and there is molten aluminium into it, it can measure the height of the molten aluminium. And if the length and width, of course, the container has a fixed length and width, so we can use it to calculate the volume of molten aluminium in that container contactlessly. Instead of putting a long rod into the molten aluminium to get the height and then compare it with some scale. On our list at number 3 are improvements to mobile app and website. So on your right, you can see ejinnovate.web.app. It is a web application, it's a website, so anyone can run it and they can see the value, average, smallest, largest for each of the 5 types. Okay, and on your right is a mobile app. It's a simple mobile app and it just updates the values in real time, but currently it's just for Android. So these are very basic, but the improvements are first, we will be adding a graph very soon. It will update in real time and we can see the past history on a graph on a scale, and users can zoom in, zoom out to see very closer values, and they can generate using the history, they can generate CSVs or PDFs for customized reports for the values. At number 2 is users can set up alerts and notifications through the mobile app. So they can be set up if a value falls below normal or above normal, so it will inform them. And they can be customized to whatever needs or requirements they want. And at number 3 is predictive analytics. So it's an AI feature which can which can analyze the previous data for the same value, and if it can check if on the same value the previous data had a higher or lower value, and it can see the previous trends to predict the next value. So at this value, if the value is above or below normal, it can sense it using its AI algorithm, and this can avoid faults later on using predictions using artificial intelligence. At number 4 is user user authentication and roles. So it's a very important requirement for every app. So only authenticated users can use the app, and they have limited access to what resources they can see. So, for example, a supervisor can see a little higher things, a finance manager can see different things. etc. It's just the roles I'm talking about. At number five, last but not the least, is geospatial integration, and that is one of the most important of this device. That is the place where the value it took from. It should store a, a location for that value. So once it updates, we can see that this value was from this specific area, and that's actually not very hard to integrate. So if there is a fault of normal or abnormal values at a specific location, we can instantly trace it out and solve the problem at that spot. So these are not all, but the most important ones. And finally, at number four, we have health mode. That is a feature which aims to revolutionize users' well being. So, in health mode, we have, let's consider the device. We have three sensors in it. The first one is temperature sensor. So if a person stays for a long time in a very high temperature environment, so it will raise an alarm and remind the user to wear protective equipment. Of course, he will be wearing in most cases, but remind him to go to cooler areas for to cool down his body. So this will prevent heat strokes and other heat related issues. And secondly, the sensor it will have is the MOX gas sensor SGP30. So it can measure the quality of air. So in casting, there are fumes which are released into the environment. So they can cause lung diseases, lung problems if a user is not wearing a mask. So for prolonged periods, it will inform the user to go to an area where the air is cleaner, etc. And the third sensor is the magnetic field sensor inside it. So if the magnetic field, so studies have shown if a magnetic field value is very high above normal, which is in that area, so that can cause headaches, increased headaches or migraines. So prolonged time strays can increase that chances. So it will prevent the users from all of these problems. And of course, they're not all. It's a beginning of the health mode in this device, and I will be expanding it with more and more and more features for users' well-being. And it's something I have not seen in most of the devices. Like a temperature sensor has a temperature measurement sensor, a voltage measurement device has a voltage measurement sensor, but no one has this health mode thing inside it. But we will be having it very soon integrated into this device. Alright everyone, so I have reached the end of my video, and we covered pretty much all the features of the device as well as its demonstration at my house and in the industry. So I guess we are done, and until next time, take care, bye, and thanks for watching.